Alright, I want to show you how to rationalize the denominator in this problem here. And what that simply means is we do not want to see a square root anywhere in the denominator. So we want to get rid of that. And the way to do that is to multiply both the numerator and the denominator by the conjugate of the denominator. Now a conjugate is simply the exact same two terms that you see in the denominator, except that the middle sign is different. We change the sign that we see in the middle. So we're going to multiply both the denominator by radical 13 plus radical 11 and the numerator by the same thing, because I hope you see what I just wrote here in red is really just a giant 1. That's all it is. So multiplying anything by 1 isn't really going to change it. Okay, so let's take care of the denominator first. When we multiply by conjugates here, we have a binomial in this denominator and a binomial in this denominator. We really are doing a FOIL. I hope you see that. But it turns out we don't have to do the O and the I in FOIL because those terms, the outers and the inners, are just going to cancel each other out. That's the whole point of multiplying by a conjugate. So I'm just going to concentrate on the F and the L. The firsts are radical 13 times radical 13. Well, that's just a 13. I hope you see that it's really the square root of whatever 13 squared is. I think it's 169. But it comes out to be a 13 anyways. Then we'll multiply the lasts. That's radical 11 times radical 11, which is just an 11. Now a positive times a negative just gives us a negative. So my entire denominator turns into just a 2. 13 take away 11, or 13 minus 11 is 2. Alright, well, let's do the same thing in the numerator. We're going to FOIL the numerator here. Now this one these are not conjugates, so we do need a full FOIL for this problem. For this numerator here. Whoops, that's F-O-I-L. So I'm going to do all 4 of these multiplications here. Right? So radical 13 times radical 13 is, again, as we saw earlier, just a 13. Radical 13 times radical 11 is going to give us the product of 13 times 11. There we go. It gives us 143. We'll do the same thing for the inners, but I hope you see that that really gives us the exact same term. So we're writing it twice here. And our last is going to be radical 11 times radical 11, which is just 11, no more radical. Now, when we're done here with the numerator, we're going to just clean up any like terms that we can by adding them together. So our numerator is going to have a 24 in it. And these two terms here in the middle are the same. We can add them together. And the way to do that is to simply add the numbers out front, called the coefficients, and we keep the radical the same. Now that's it. We're done with this problem, except that if you're doing this on My Math Lab or on a quiz or a test, and the problem says to simplify as much as possible, I hope you see that we can actually factor out a 2 from both of these terms in the numerator. Again, I'm not messing with the number inside the radical, just the numbers out front, just these coefficients here. And if I factor out a 2 from that, I'm left with 12 plus really just a 1. I don't really need to write the 1. But I'm left with 12 plus 1 square root of 143, and now we can actually cross out this 2 in the numerator with this 2 in the denominator, giving us our final answer of 12 plus really a 1 if you want to write it there. I don't think that's anything wrong with that, plus the square root of 143. So there's our final simplified answer for rationalizing this denominator.